Hey guys, this is my last lesson. It's on titrations. If you've never done a titration before, I'll put a video up for you. You can check it out on my chemistry YouTube channel. There's a whole demonstration of titration. I'm just going to go through this briefly, what I drew here, so that everybody kind of gets the general gist of a titration. Some of you already did this in Chemistry 20. Good for you. For those of you who have never done it, this is what a titration does. Okay, you put 10 milliliters of hydrochloric acid into this is an Erlenmeyer flask. Okay, that's the name of this. You should know this. Erlenmeyer flask. Okay, that is an Erlenmeyer flask. It's kind of shaped like a funnel. And what you are doing is you're adding base, okay, to this acid. So now this is your base, and you don't know what concentration of base you have here, but you added, you can see here, 0, 20. Okay, so how much base did you add into this? It's called a burette. Okay, so this over here, there, that's called a burette. Okay, and this burette, you can actually turn it on. And when you turn it on, right, this is called a stopcock, you turn it on, and then guess what? The base is added to this acid. That's all you're doing. Now, you've already added 3 drops of phenolphthalein. Now, what is phenolphthalein, you guys ask? Hey, it's an indicator. It's on page 12. And guess what? It's colorless at 8.2 or less. Okay? It's pink at 10.0 or greater. Okay? And so what is happening is this HCl is initially colorless. Okay? So initially, this HCl is colorless. Okay? But what's going to happen when you add this base? If you add this base, is it going to become more basic? It will. And so you're going to start to see is if you turn this on, the base comes in, and the acid goes from colorless, and you want to get a light pink color. Once you get this like light pink, you have reached what we call your end point, and your titration is finished. Okay? So basically, what you've done is what you've indicated is a pH basically between colorless and like almost 10, just about 10 where you get to pink, okay? That's all you do in a titration. Now, things you gotta know is the name of this structure is called a burette. You put the base there, you don't know the concentration of the base, but when you open this, the base starts moving into the acid, right? Once you hit this light pink color, you stop. You stop adding base in. So let's say it took about, I don't know, 10 milliliters to turn the acid pink. Let's say that's all it took, about 10 milliliters, okay? So now what's going to happen is this is the base, and now you've taken the base and you put 10 mils of the base. And it took 10 mils to change this colorless HCl to this kind of light pink color, right? That's how you do a titration. And that's basically it. I mean, you can watch the video if you want. It will help. We do a lot of methods, but we just kind of can't do it here because, you know, we don't have a lab. I'm trying to show you on this whiteboard how you do a titration, okay? So this process, what we just did here, is called a titration. All right? Hopefully you understand what this is about, because you got to do calculations involving titration, okay? So what I'm going to do is I'm going to erase this, okay? And we're going to just make sure you understand, okay, that when I had the Erlenmeyer flask with the HCl in it, I said that I had 10 milliliters of this, and the concentration was 0.50 moles per liter, okay? So you already know this, okay? So I added 10 mils. I use like a really fancy method called a pipette. basically, yeah, have a bulb and you measure 10 mils, okay? So you have 10 mils and of acid, and you pipette the acid in here, okay? So you have 10 mils of this, you have the concentration of this, okay, of the HCl, and then when we did our titration, okay, so when we did our titration, we said it took about 10 milliliters of the base to turn it this light pink color, okay? Remember, that's what we call your end point, okay? Is this kind of light pink color, okay? So I added 10 mils of base to get this light pink color, but my concentration of my base, I don't know what it is. So I gotta do a calculation. Now the calculation is really easy. When you have the knowns here, and then you have one unknown over here, you use this C1V1 is equal to C2V2 formula to figure out your unknown concentration. Okay, so we're gonna do that. And by the way, you're gonna see this on your science booklet if you guys are gonna eventually do these questions, and it asks you where is the end point. Okay, so the end point is always in the middle here, and that's where the end point is, and that's basically when it changes to that light pink color. Okay, so it's always in the middle of this like line, right? So you start at a basic pH here, and you can see you're becoming more acidic over here, and basically this is the point where it's kind of gonna turn color. Okay, just so for your information. But we're gonna go back to this formula. C1V1 is equal to C2V2. So basically, let's just, HCl, right, I said was 10 milliliters. Hey, C1V1 is equal to C2V2. C, whenever you see C, that just means concentration, okay? So C is equal to concentration, and V, and that's measured in moles per liter, and V is equal to volume, and that's measured in milliliters, okay? It doesn't matter. You'll see you don't need to convert units here. So remember, the HCl was 10 milliliters, and we had a concentration of 0.15 moles per liter of that. Hey, guess what? I'm going to make this my V1 volume, which is in milliliters, and I'm going to make this my C1, okay? So C1 is my concentration of the HCl, V1 is my volume, okay? And you can see that the HCl, I made the HCl V1 and C1, so both V1 and C1 are the acid. And then when you look at the base, NaOH, I said I had 10 milliliters of the base, which is then V2, and that I don't know what my concentration of my base is. I don't know what that is. That's my C2. That's what I'm trying to find. Okay? So just notice that for the acid, I made the milliliters and concentration for the acid my V1, C1. So you can't go like 10 milliliters of the acid, V1, and then you can't make your C1 the NaOH. Like both the C1 and the V1 have to be with the acid, and the V2 and the C2 have to be with the base. Okay, just to note that. Anyways, when you guys do your calculation, okay, with the C1, V1 is equal to C2, V2, okay, well, C1 is the 0.15 moles per liter. V1 is 10 milliliters. You don't need to cancel you don't need to convert this to liters. It'll work. Is equal to, I'm going to run out of room here, so I'm just going to, 0.15 times 10 milliliters is equal to C2. That's my X. I don't know it. And V2 is equal to 10. Okay, so how do I solve for X? Okay, well, you got to take your calculator, right? And so what you're going to do, okay, for your calculator, you're going to go, okay, 0.15 times 10 is equal to, okay, 1.5 is equal to 10 times X. That's what you do. And you want to solve for X, right? You want to solve for this. So you divide both sides by 10. And then what do you get for x? X is equal to, well, what's 1.5 divided by 10? That's equal to 0.15. Hey, guess what? I just solved my concentration for x. The concentration for x, right, is 0.15. So now I know what my concentration of NaOH is, 0.15. And that's all you do to solve for titration calculations. Okay, so we're going to try this one here on page 29 in your book, just to make sure everybody understands how to do this. Okay, and it says if it takes 12.2 milliliters, okay, so you have 12.2 milliliters of 0.15 moles per liter of NaOH, okay, and to neutralize a 20 milliliter sample of HCl, what is the concentration of HCl? So you don't know what this is, right? That's what you're trying to find. So what do? Okay, well, this is going to be my V1. That's going to be my C1, right? Because the acids were 1. We're going to make the acid V1, C1. And the base is V2 and C2, like that. And then I just use that same formula. C1 V1 is equal to C2 V2. Okay, so my V1 is 20 milliliters. My C1 is my X. I don't know what it is. My C2 is 0.15, and my V2 is 12.2. Okay, now that's all I do. So then how do I solve for my X? Okay, well, first let's multiply this. 0.15 times 12.2. So I go 0.15 times 12.2 will give me 1.83 on that side. Okay, and then I have 20 milliliters times x, so we'll just get rid of this so that you get 20x, right? 20 times x, you don't know what that is. How do you solve for x? Divide both sides by 20, and guess what you get? X is equal to 1.83 divided by 20. Oh, my answer is 0.0915. Hey, guess what? I just solved for my concentration of HCl. The concentration of HCl is 0.915 moles per liter, and I'm good, okay? So that's all you guys got to do. Don't worry about sig digs. They'll tell you how many digits they want your answer in. You guys are going to be doing page 28, 29, and 30. You're going to try this. For this question over here on page 30, question 10, I mean, what you got to do is it gets you the initial burette is 1.4. The final burette is 17.1. So what you guys got to do is go 17.1 minus 1.4 and find the difference, okay, between 17.1 and 1.4. And that gives you 15.7 for that. And then the next one is 32.7 minus 17.1, which means the difference is 15.6. And then you get 48.3 minus 42.7, and the difference is 32.7, sorry, is 15.6. And then what you do is you average these three. So you add the three together, 15.7 plus 15.6 plus 15.6 equals, and divide it by 3, and that, so divide that by 3, so add these together, divide it by 3, to get an average volume of 15.6 milliliters, okay? That's what you do. You're supposed to do 3 trials to get that light pink color. We didn't do it because we don't have a lab. Anyways, there's that titration video you guys can see. I hope that helps. All right, this is the last lesson, and your homework, get it done. Hope you guys are doing good. Hope that's clear. Bye.